Hey guys, welcome to question MM229 of the Maths Methods Fortify study guide. In this question we've got this function f of x equals a log e of ax minus 2x, where a is a positive real constant. What we're trying to find is the x coordinate of the stationary point of the graph of y equals f of x in terms of a. Awesome. So as always guys, a stationary point occurs when the gradient of the function equals 0, right? So whenever we're dealing with these kind of questions, we've always got to actually find the gradient function and then let it equal 0. So how do we find the gradient function of this? Well, our gradient function is f dash of x, and because these are two separate functions, we can kind of treat them as if they were separate. So the derivative of log e of ax, according to our formula sheet, is simply 1 on x, right? But we've got this a at the front, so we've actually got a times 1 over x. 1 over x is our derivative of log e of ax, and our derivative of take away 2x is take away 2. Awesome. Which means that our f dash of x is equal to a on x minus 2. As is your first mark, finding this gradient function. But we're actually looking for the value of x that the stationary point occurs at. So we need to let this equal 0. Let f dash of x equal 0 at stationary point. Therefore, 0 is equal to a on x minus 2. So 2 equals a over x, 2x equals a, x equals a on 2. This is your second and final mark for this part, because all we're asking for is the x coordinate in terms of a, which is exactly what we found. So that's that. Let's move on to part AII. Part AII asks us for the range of values of a such that the stationary point of y equals f of x lies above the x-axis. Awesome. And this is a 2-mark question again. So, yeah, that's all good. So let's just write this down again. So x equals a on 2 at the stationary point. Awesome. And we're looking for the range of values of a such that the stationary point is above the x-axis, okay? If it's above the x-axis, so everything above here, that means that our y value is greater than 0, right? So y is greater than 0 if it's above the x-axis. So that's going to be really important here. So we know that f of x is equal to a log e of ax, but we're looking for our stationary point, right? And we know that our x value at our stationary point is a on 2. So at our stationary point, f of x is equal to a log e of a times a on 2 minus 2 times a on 2, right? Because we're just subbing in a on 2 for all of our x values. If our y value is greater than 0, that means that f of x is greater than 0, right? Which means that this section here, this function, is greater than 0. So a log e of a, and I'll simplify this as I go, like 2, a on 2, is greater than 0, right? Because this is our f of x, or our y value. And if it's above the x-axis, again, our y value is greater than 0. Recognizing this is your first mark. So this is where the first mark comes in. Now we simply just need to solve for a, right? Because we're looking for a range of values of a. So let's just do with this. So a log e of a squared on 2 minus 2 times a on 2 is just a. Greater than 0. We're going to take a out as a common factor. So we get a log e of a squared on 2 minus 1 is greater than 0. We're actually going to divide both sides by a to get rid of that a. And we already know that a has to be greater than 0 because it's in this function here. So a is greater than 0 is like its own thing, but we already know that a has to be greater than 0, so we can kind of cancel that. So log e of a squared on 2, take away 1 is greater than 0. Log e of a squared on 2 is greater than 1, so this negative 1 comes over here. Let's just come back up here. So then e to the power of 1, and the way that this works with logs is you take your whatever's in here, and that's what comes before this sign. As in, what you'll actually get is a squared on 2 is greater than e to the power of 1. So this can be a bit weird as opposed to just having an equal sign. But what you need to remember is whatever's inside the brackets is what goes before the same sign that you've got there. So a squared on 2 is greater than e to the power of 1. That's how we rearrange our log, which means that a squared is greater than 2e. Square root of both sides means that a is greater than plus minus the square root of 2e. But since a has to be greater than 0, a is greater than positive root 2e. That is our second and final mark. Now I know this is a lot of work for 2 marks and it is quite a difficult question. But the main thing is recognizing we found the x value in the first part for a reason, and the reason was so that we could actually find this. And the other part is lying above the x-axis, meaning that y is greater than 0, so just keep that in mind as well. If you have any questions about it, just chuck them in the comments below and I'll answer them. But for now, let's move on to part B. So part B says 3 marks. Part B says, for a certain value of a, the tangent to the graph of y equals f of x at x equals 2 passes through the origin. Find this value of a. Awesome. So let's imagine this as a line passing through the graph. Actually, I'm just going to get rid of this so I can put it here. Let's just get rid of that as well. So we've got this graph. We don't know necessarily what this looks like, but we know that there's a tangent to the graph at x equals 2, so here, that passes through the origin, right? So we've got a line that goes up through here that's also a tangent to the graph at this point, okay? So the gradient of this graph is going to be rise over run, right? So you can kind of see this is a triangle. It's going to be rise over run, but it's also a tangent to this function. So it's going to have the same gradient as this function at x equals 2. So that's going to be our key here. So we need to recognize that our gradient of our tangent is equal to rise over run as normal, so from this point to this point, but also f dash of 2, right? Because it's the gradient of this graph at x equals 2 because it's a tangent, okay? So next thing is we know that f dash of x was equal to a on x take 2. We know that f dash of 2 then has to be a on 2 minus 2. Sweet. So that's our kind of first thing there. Our rise over run, we know is equal to y2 minus y1 over x2 minus x1. But we've only got 1 point at the moment. We've got 0, 0, which is fine because we know it passes through the origin. We know that it passes through x equals 2, but we don't know what our y value at that point is. So we're going to need to find that just by subbing in f of x, okay? So our first point, y2, is going to be our y value of this function. So a log e of, we know that our x value is 2, so we get a log e of 2a minus 2 times 2 because x is 2, so minus 4. Our second y value is 0. First x value is 2. Second x value is 0. Awesome. So from here, actually, you know what, let's combine these. So we know that our gradient is equal to this, and it's also equal to this, right? Because f dash of 2 is equal to rise over run. This is f dash of 2, this is rise over run, so we can make these equal each other. I'm just gonna get rid of this. So therefore, a log e of 2a, take away 4 over 2, so that's just this section here, is equal to a over 2 minus 2. Awesome. So multiplying both sides by 2 to get rid of these 2's and that 4 can change, we get a log e of 2a minus 4 equals a take 4. Awesome. These negative 4's can cancel out, and we get a log e of 2a equals a. Rearranging this, we can get a log e of 2a minus a equals 0. Take a common factor of a out, a log e of 2a minus 1 equals 0. Awesome. And so according to our null factor law, a is equal to 0 and a is equal to log e of 2a minus 1. Awesome. Coming back up here. That's fine, we can kind of just leave that how it is, but this we're going to need to solve. Actually, sorry, this was 0 equals log e of 2a take 1. So from here, 0 equals log e of 2a take 1, which means that 1 is equal to log e of 2a, e to the power of 1 equals 2a, which means that a is equal to e over 2. Awesome. So we know that a is equal to 0 and a is equal to e on 2, but because a is inside our log over here, a cannot equal 0, right? So a cannot equal 0, therefore a is equal to e over 2. And that is our final answer. So guys, as we go along, I didn't put down the marks. The first mark comes from when you recognize that rise over run equals f dash of 2. So that's your first mark. Your second mark comes when you get to our null factor law section where we have a 1 take log e of 2a, or log e of 2a take 1 equals 0. That's our second mark. And then our third mark is a equals e on 2 as your final answer. And you really need to make sure that you discount a equals 0 because it's just not going to count. It's not a valid answer. Awesome. So guys, if you have any questions about that, hit me up in the comments below. But otherwise, thanks for watching and see you in the next video.